All right, guys, moving into 4-7. We got a quick warm up here, so go ahead and give it a shot and pause the video and then play it back, and we'll go over it. All right, so number one, just practicing your congruent statements here. We have triangle ABC is congruent to triangle DEF. So first off, they're saying angle A is congruent to what angle? So first thing you need to recognize, again, angle A is the first vertice listed in the first triangle, and D is the first vertice listed in the second triangle. So this one would be angle D. For BC, we're looking at the last two vertices listed in the first congruence statement for the first triangle. So the last two vertices in the second triangle would be EF. So this would match or be congruent to triangle, or not triangle, segment EF. So that would be number one. Number two, you can use that distance formula or Pythagorean theorem. It just depends on which way you want to do it. I will draw it and then talk about both methods as I do it. But here we have the 0.34, so 1, 2, 3, 1, 2, 3, 4, so the 0.34. Then I have the point -1, 5, so -1, and this goes up to 5. So we're finding the, wow, that's ugly. We're finding the distance between those points. I'm going to try to connect them with a line. I'm not very good at drawing straight lines on here, but what I said, you can use Pythagorean theorem if you set up a right triangle between those points. If you did that, this distance or the height would be 1. You can also look at the points. 5 minus 4 is 1. If you go from -1 to 3, that's 4. So this would be for the distance. Think of it as c squared equals a squared plus b squared. So c squared equals 1 squared plus 4 squared. So c squared equals 17. So c is the square root of 17. So that's going to be your distance. Now, obviously, that's like 4 point something. Square root of 16 is 4, so it's a little bit above that. But if you're going to solve this using the distance formula, you would go distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared, which is the same as the square root of a squared plus b squared. Because if you simplify this, x2 minus x1 is going to be, 3 minus a -1, so plus 1, plus y2, and I'm doing it this way, I'm calling this my x2, y2, because you see how I did 3 minus a -1 on the first one, so I'm going to go 4 minus 5 here. That would be -1 squared. So I end up with 4 squared, so 16, plus -1 squared, and a negative squared is positive, and I get the same answer. So long story short, square root of 17 is going to be your distance, whether you do distance formula or Pythagorean theorem, because in a way they're kind of the same thing. Alright, so number 3, it says angle 1 is congruent to angle 2, so we know these two angles are congruent. Well, if those two angles are congruent, why is A parallel to B? Well, these are alternate interior angles. So this is actually the alternate interior angle converse theorem. And we gotta remember those theorems, they don't go away. So we're able to prove that those lines are parallel because of the converse theorem. Remember, the alternate interior angle theorem says if the lines are parallel, then the alternate interior angles are congruent. The converse theorem says the opposite of that, and that's kind of what we have. If alternate interior angles are congruent, then the lines are parallel. So that's number 3. Number 4, list the methods used to prove two triangles congruent. So again, those methods would be side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Remember, these are the ones that work. The ones that don't work, it's easy to remember which ones don't work, and then the remaining scenarios are the ones that do. I always say, remember, angle, angle, angle doesn't work, and I always use the example of two equilateral triangles that are one's bigger than the other. It's the easiest way to remember it, because these are all 60-degree angles if they're equilateral, but they're not the same size. And the other one is side-side angle. I'm not going to write angle, angle, side, but remember, it's a pane in the angle, side, side. Easy way to remember those, okay? So you can kind of keep them straight in your head. So know the ones that don't work. These are the ones that don't work. These are the ones that do work, okay? Again, if you just know these two don't work, then by default the others all do. So there's your warm-up. Again, all these are going to be used in this lesson. As you can see, there's a lot going on in 4.7. We're trying to throw everything together that we've been learning up to this point to learn about what CPC/TC stands for. Alright, so our goal today is obviously to use this CPC/TC. You got to figure out what the heck it means. It'll show that in the next slide here. But you're going to be able to use that concept to prove parts of triangles congruent. So again, let's explain what this means. So CPC/TC means the following: corresponding parts of congruent triangles are congruent. Notice I circled C, P, C, T, C. We need to know what that means, or else, unless you want to write the whole thing out every single time, I would advise against that. So again, we're going to use this as our proof statement. So when we're doing a proof, our goal is to basically get two triangles congruent. Our reason for that should be like side angle side, side side side, angle angle side, angle side angle, hypotenuse leg. You're trying to use one of these theorems to prove the triangle's congruent. Now, let's say I said triangle ABC is congruent to triangle DEF. What we would do here is we're going to use CPC/TC to show that if these triangles are congruent, then all the corresponding parts in that triangle are congruent. So the proof would not be to prove that the triangles are congruent. The proof would be to say, well, prove to me that AB is congruent to DE. Well, our goal then, if we're trying to prove this, is to first prove this. If we can prove that the triangles are congruent, then I can make this statement. Why? Because corresponding parts of congruent triangles are always congruent. That's going to be a reason. So this is kind of what we're going with here. We're going to be still doing our proofs, proving triangles congruent. We're just going to go one, maybe even two steps farther, because we'll be using some of those converse theorems in one of our examples, you'll see. But we're just going to kind of add on to it. But it's the same basic idea. You're just adding this little thing or idea concept at the end. Okay, so that's really what this whole lesson's about. It's more about reviewing those proofs, but adding a step while we do it. So as I said before, these are the theorems that work. We got that in the warm-up. I just mentioned it kind of in that little proof statement. By the way, you may want to write like a quick sketch of this down. Like this is pretty much what we're going to be doing in this lesson. So you want to have a general idea how we're going to approach proofs in this lesson. The idea is to prove the triangle congruent, then make your congruent statement after it. That's the main idea of this entire lesson. So make sure you understand that. All right. So first example is pretty easy, honestly, and then we'll kind of get into our proofs. But this is just kind of explaining the concept of CPC/TC. Okay. So this one's giving you, long story short, I mean, this is giving you a figure, describes the, JK is going to describe the distance across the pond. They want you to find that distance. So this is just a simple concept here of using congruent triangles to make those conclusions. As you can see here, we have two congruent sides here with the 19 and the 19, and we have two congruent sides here with the 30 and the 30. We also have congruent triangles because these angles are congruent through vertical angles. So I have a side angle side relationship. So again, I know that triangle JKL is congruent to, and you know what, a lot of students really screw up these statements here, so pay attention to this, like how I'm writing out this congruent statement. I just said JKL. So notice here, that KL is 30. So a lot of people just don't really care. They just go MNL. And then they get this wrong. Because if I just said triangle MNL, like if I do MNL, notice how NL would be my last 2 points. But NL doesn't match KL. Order matters. This would have to be written as NML if I'm writing my congruent statement. You can see how ML is 30. That's the last 2 points here. Well, KL is also 30. Remember what I've said numerous times, order matters if you ever write a congruent statement out. So anyway, what we know from this, and by, they're congruent by side equals side, what you should know by this, that KL is congruent then to ML. So I know that KL is congruent to ML by CPCTC. So if you're trying to solve this, they want JK. Why did I say ML? I mean, they are, but that's not the one I'm looking at. I'm sorry. I was kind of getting caught up in that other statement. Okay, sorry. I know MN is congruent to JK. So JK and M, I'll do KJ to go in the same order. Doesn't matter. It's the same segment. But I know those two are congruent. Now KJ is the same as JK. So since these are congruent, I know that MN is 41, so JK is 41. So long story short, I'm just trying to explain kind of what we're getting at here. But that's 41, and I'm using CPCTC to show that. And that's kind of what that means. Corresponding parts of congruent triangles are congruent. So since MN was 41, JK was 41 by default. Okay. Overall, like I said, that's a pretty simple example, though. Really, all they're looking for is JK, and that's it. But I just want to explain the reasoning behind it. All right, now we can do some proofs. Okay, so getting back into the proofs, we have some phrases we've used on proofs in earlier sections here, but with bisectors and things like that. So we're going to basically just show you, I'm going to show you how to do a proof. Well, we're not really proving triangles congruent. We're trying to prove that corresponding parts of those triangles are congruent. But again, this is the big concept from this lesson. You got to understand what it is we're trying to do if I'm asking you to prove corresponding parts congruent. So our concept is to prove the triangles congruent. If I can prove the triangles that are congruent, then I can say that corresponding parts of those triangles are congruent. And for example, PQ is congruent to PS. So that's going to be my goal as I go through this. Prove the triangles congruent, then I can use CPCTC to write my proof statement. So it's going to be one extra step. That's it. So let's start off the same way we would do a proof in the previous lessons. Write out our given statement. PR bisects angle Q, not R, QPS, and angle QRS, which is given. Alright, so here we go. Step 2. Since PR is bisecting both of these angles, QPS, QPS, QRS, I know these two angles are congruent, and I know these two angles are congruent. So I need to label that, and I can do that in one step using definition of angle bisector. I'll even write that out now. Again, we've used this one before, so it's not new. So I know that angle, be careful guys, you write this QPR, angle QPR is congruent to angle SPR. So I got that out. Next, angle QRP is congruent to angle SRP. Again, that's definition of angle bisector. Next up, remember they share a side. That's our reflexive property. So we can write that out real quick. PR is congruent to PR. That's the reflexive property. reflexive property of congruent. At this point, I'm ready to do angle side angle. I can prove my triangle's congruent. Now here's where you got to be careful. Make sure your congruent statement doesn't lie. So the first one was going to go triangle PQR. Now it looks here like I started with my one arc angle, which was P, so I have to start over here with P. Remember guys, order matters. I will be checking order. If it's not written in the right order, it is wrong. So if you went RSP, that would be incorrect. It has to be P, S, because that matches with Q, and then R, PSR. Again, this was angle, side angle. Now, because of all the postulates, theorems, kind of we've been going over, I'm actually going to be fine if you guys just do angle, side angle, or side, side, side without writing postulate or theorem, just for these, because they kind of, honestly, you can prove all of them, so they can all be theorems, and most of them are postulates anyway, as well, because you can kind of show them without having to do a full proof. So if you give me just angle, side angle, I'm fine with that. But here's the thing, though. We have one more step. This would be like a question from 4.6 or 4.5. But 4.7, we're proving segments congruent. So I have one more step. That's all. I have to go PQ is congruent to PS. And here's the thing. I know since these triangles are congruent, I know any corresponding part is congruent, including those sides. So that would be CPCTC. And this is the 4.7 work. That's the new stuff. That's it. We're adding one step to our proofs. So there we go. CPCTC. Make sure you say that right. Not CCPCT or whatever the heck you may want to do. Corresponding parts of congruent triangles are congruent. Okay. Alright, so we're going to do one more here, well, there's two more proofs. But the next proof we're going to do is going to add two steps to the end. And again, if we're proving triangles or lines parallel, remember converse theorems / postulates. We're going to be using them here, okay? Be ready. So let's do this. Okay, so in this one, I'm going to draw this picture off to the side because you can't really see it. It got cut off there. This is KL. Move this down. I can never draw straight. And that's going to be J, M, and N. So there's your figure, okay? So J is a midpoint of K, M, and NL. So we got another midpoint here. Right? Again, it's just like a segment, okay? So we've done this before. If it's a segment bisector, you just use definition of segment bisector. If it's a midpoint, we use definition midpoint, but the concept is going to be the same either way. So when they say J is the midpoint of K, M, and NL, so that means that these segments are congruent, and these look like they're all the same, but they didn't tell me if it's at this point, if we know it's a rectangle or not, so I'm going to use two dashes here. Okay. But anyway, I can say that those segments are congruent. I'm not talking about these last couple steps here. I'm going to do that when we get there, because everything leading up to step 4 is stuff we've already done. So let's just kind of go through this proof, and then I'll talk about what this proof statement is asking us to do, if you don't already know. So this would be the reason that these are J's a midpoint. Well, that's just going to be given. But then we had our next step. We said that JN and, here we go, NJ and LJ, so these two segments are congruent, and they said these two segments are congruent. Well, that's because we knew they were that J was the midpoint of those segments, so this would be definition of midpoint. Next up, you have these angles. They're giving you two angles are congruent, so KJL, so KJL, so that's angle right there, and MJN, so MJN, so these angles right here, which are vertical angles, so we'd say the vertical angle theorem. And it looks like we have a side angle, included angle, side, so I can use side angle side to say that my triangles are congruent. So this is stuff, again, we've done before, but now they're wanting you to prove that KL is parallel to MN. So KL They want you to prove this. These two are parallel. Well, in order to do that, we need to use one of our converse theorems. And if you look, they're going to tell you which angles are going to show. But if you see the triangles here, the two triangles I proved congruent, remember, I can say that any part of those two triangles are congruent now. It looks like they're doing LKJ, so LKJ, that's this angle right here, and NMJ, NMJ, this angle right here. So you're using that to say those two are congruent. Again, remember, these triangles are flipped. See how this one dash is on the right here, one dash is on the left here, so these are corresponding parts because the triangle's been flipped. So anyway, we can use CPCTC here, and notice, I'll just draw the figure with, pretend like this is my KL and NM, KL, NM, and this is KM. Okay? Well, they just shown that these two angles are congruent. Well, if those two angles are congruent, then those lines are parallel by the alternate interior angle converse theorem. And that's about as crazy as those proofs will get, where you have two steps after our triangle congruent statement. It's either going to be showing that corresponding parts are congruent, and that's what we're trying to prove, or trying to prove lines parallel. If you are, then it's going to take two steps. But that's it. That's it. Okay? So it's what we've been doing, just adding a couple steps towards the end of it. Alright, last one here. And this one will kind of just show using distance formula or Pythagorean theorem. They want to prove that two angles are congruent. So this one, they're giving you points. So your goal or your plan of action for a problem such as this is to graph this. And that's how we're going to do this proof, okay? We're going to show it algebraically. So I'm going to plot all these points, and I'll pause the video. You can give yourself a second to and label these points on a graph, then we'll talk about what we're going to do next. Alright, so here we go. Now in the beginning of this chapter, we were able to prove figures congruent using transformations, and that hasn't gone away. It's not like you can't prove it that way. I'm just showing you this is another way you can prove the triangles are congruent. And once we show the triangles are congruent, we can then use that to to prove the angles congruent. Remember, CPCTC will be coming up again. So I just want to show you how, again, you can use distance formula here. We're going to start by looking at JK, and we're going to look at, and just think of this, bam, cut that down the middle, at RS. So I'm going to try to compare those two sides. So if you look at JK, that's -1, -2 to 2, -1. So I'm looking at this distance right across here. Well, that distance I can just count in a way. It looks like I labeled it wrong, right? So I got 2, -1. So let me fix that real quick. I'll pause it and I'll come back. Okay, so now I can find this. So if I'm going to do JK, so I'll find that distance. It's going to be, again, just using Pythagorean theorem. Looks like I'm going to go right from -1 to 2, right 3, and up 1. So I'm going to go right 3, up 1, so 3 squared plus 1 squared equals 9 plus 1 is 10. So remember, if using Pythagorean theorem, remember all I'm doing here is I'm solving this triangle. You can kind of see it. This is the triangle I'm solving. So looks like I went right 3, up 1, so I'm finding C, right? So this would be C squared is 10, therefore C is the square root of 10. So I have JK. Now I want to compare it to RS and see what I get for RS. So you come over here to RS, looks like I'm going from 2, 3 to 5, 2. So I'm looking at this distance here. So I'm going to find this distance by setting up this right triangle. So you can set up this triangle again, so you see what I'm doing here. It's that triangle right there, and I'm trying to find that distance. So if I'm setting that up, it looks like I'm going from 2 to 5, so I'm going right 3 again, and I'm going from 3 to 2, so I'm going down 1. Well, you can just see the sides, and you can see that that's also the square root of 10. So I know that these two segments are congruent. Now because this, I'm not really given angles here, it looks like I need to do side, side, side. So I'm going to kind of go side, side, side on this. So the next side I'm going to do KL. And then I'll do KL matches with ST. So if I'm doing KL, that's going from 2, -1 to -2, 0. So 2, -1. Let's see. Oops, I gave you the wrong length down here. Oh well, I'll fix it later. Okay. So anyway, what I've labeled before, I found these two segments are congruent. I'm going to try to prove that segment from -2, 0 to 2, -1, that's KL. I'm going to try to show that it's congruent to ST, which goes from 5, 2 to 1, 1. So I'm trying to show those two segments are congruent right now. Okay. So for KL, looks like I'm going again from -2 to +2. So the horizontal distance on this triangle is going to be 4. And if you're going to go down, it's going from 0 to -1. So that distance is going to be 1. So again, this would just be 1 squared plus 4 squared equals c squared. So c is the square root of 1 plus 16, so 17. So KL is 17. Now ST, I'm doing ST, I'm getting this distance right here, so I'm going to go from 1 to 5. So I set up this triangle. I'm going from 1 to 5, so right 4. I'm going up 1, so up 1. Notice it's the same lengths, so that would also be the square root of 17. You probably get where I'm going with this. I'm trying to show that I can prove all three sides congruent, and I can use side, side, side. So my next set, go right here, find those links. So for these last links, it looks like I'm gonna, if I set up my triangle right there, looks like you're going right 1, up 2, come over here. Looks like I'm going from 1 to 2, so right 1, and from 1 up to 3, so up 2. See how these are the same lengths? So my last sides, which would be JL and RT, those are going to both be c squared equals 1 squared plus 2 squared. So c is the square root of 5, and that would be the square root of 5. So if you know what I'd be looking for if I was grading this, if this is like a problem on a test or whatnot, I'm looking for these lengths. You need to show me that these all have the same lengths, all the corresponding sides. If you can do that, then you can do the following statement. You can then say that triangle JKL is congruent to triangle RST by side, side, side. Therefore, angle JKL is congruent to angle RST by CPCTC. And again, there's more than one way I can take an answer here. If you want to go back and review the concepts from the beginning of this chapter, you can also prove these figures, or these triangles, congruent by your transformations. So don't forget that as a method, okay? And I'll take either one. It doesn't matter to me, as long as at the end you use this CPCTC statement. Okay, so those are really the proofs that we have for this chapter. Applying CPCTC, it's a lot of review, as you can see, of things we've learned in this chapter and in the previous chapters with our converse theorems. So from here we got our lesson quiz. So the first one is just filling in the reasons. Again, we're trying to prove that our two segments are congruent, so you should know the last step, CPCTC. You better get that, I just gave it to you. Part 2, the lesson quiz, another proof. Okay, trying to prove that X is the midpoint of BD. So again, you got the steps kind of worked out for you. But we're going to have here our congruent statement, CPCTC in step 6, definition congruent step 7. Hopefully you can fill in the rest from there. And then part 3, just like with the problem I just did. Remember, there's two ways to do it. You can either do the method I did in this lesson, or you can use the method that we used back in 4.1, I believe. So again, you have an option there. And then do your reflection, and we'll see you guys in class.